Thank you.
All right. So on Friday, we started talking about Le Chatelier. And we reviewed what Le Chatelier's principle said. All right. We said, and you wrote this down for those of you who have forgotten it, that if a system is in equilibrium, it will readjust to minimize the stress. And so we reviewed our physical equilibrium on Friday. You should not need to rewrite this because you already have it written. All right. Our physical equilibrium was our evaporation condensation system, right? Betsy, why are you back over there, by the way?
It's her birthday.
And she's going to be quiet on her birthday?
Yes, ma'am. Yes.
Uh-huh.
It's her birthday present from you for the rest of the year.
Right. Keep thinking that. So, today, we're going to talk about chemical equilibrium. So, we're going to look at 3 stresses today. And I can't remember which one I have up here first. All right, but the 3 we're going to look at are temperature, pressure, and concentration. All right. Now, the one I have up here first is, you want that slide or no? You don't need it. All right. Concentration is the one I have up here first. All right, we're going to talk about changes in concentration. Now, I told you last week that the hardest part for most of you will be the fact that you don't study and you have to learn the rules. And this is the part you're not going to do well with because you won't learn the rules. Now, the parts that you absolutely have to have are the bolded parts. If you add, and it doesn't matter if we add a reactant or product, all right, the reaction will shift to the side to use it up. Remember, we're talking about a reaction that is what? We're talking about a reaction that is at, stay over there where I had you, so y'all will stop writing for a minute. We're talking about a reaction that is what? At equilibrium, and we're disturbing it. So this reaction is trying to get back to equilibrium, right? So this statement that we're getting ready to write down is about trying to get back to where it was. How can it do that? Okay? So if we're at equilibrium and I add a reactant or I add a product, the reaction is going to shift in order to get back to equilibrium. The question is, how does it do that? Okay? It does that by using it up. Now, you don't actually have to know how to use it up. I'm just telling you that's what it does for those of you who want to know why. But for those of you who are just thinking, well, I don't care why it does it. I just need to know how to get the answer right. The bold is how you get the answer right. All right? If you add a reactant or product, it has to shift to the opposite side that you added it to. Okay? So if you add it to the reactant, what's the opposite side of the reactant? The product. If you add a product, it has to shift to the opposite side. So what's the opposite of the product? The reactants. But you have to know that rule. Now, we don't only add. What else can we do to concentration? We can do what else? Subtract or take it away. Okay? So there's a different rule for removal. Okay? If, again, we remove a reactant or product, the part that's not bolded is the reason. You want to shift to the side that's going to make more. Remember, you're at equilibrium. We just sucked out part of what you had. The reaction is trying to make more and replace it. Again, do you have to know that piece? Not necessarily, but it's important if you're going to go on in chemistry. But if you just want to get the question right, you need the bold part. You have to shift to the side you removed it from. So if you remove a product, you have to go to the side you removed it from, which is essentially the same side. If you like shorter words. Okay? So if you remove something, you have to stay on the same side. Okay? And that's the problem with these. There are rules to go with shifting, and you have to know the rules. As long as you can keep track of the rules, I don't think this topic is very difficult. But if you can't remember the rules, it's a bear. It's just a eeny, meeny, miny, mo guess. All right, you caught up? All right, we need to talk about one thing before we practice. Does everybody have what they need? All right, anytime you say the reaction shifts right, okay? And this is true for all three things we're going to talk about today. Whether we talk about concentration, whether we talk about temperature, or whether we talk about pressure, it doesn't matter which type of shifting we're talking about today. Every time you say the reaction shifts to the right, what happens to the product? Does the concentration over here increase or does it decrease? That's right. Okay? The concentration of the products increases. Okay? And it doesn't matter if we're talking about temperature, pressure, or concentration. Whatever's on the right is going to increase. Now, that means that whatever's over here is going to do what? It's going to decrease. So, the flip side of that is, if you say that it shifts left, what does that mean is going to happen on this side? It's going to increase. And what's going to happen on this side? It's going to decrease. Now, that doesn't change for temperature, pressure, or concentration. That's true for everything we're doing today. I'm going to constantly flip back and forth to this slide. Probably a lot because Tevin's missing. Now he's going to go, where'd you get that from? Nothing. You know, because he can't hold it.
Oh my God.
It's like a little old woman. Your pee-pee.
Oh, I have to pee.
Oh, there we go.
All right. So suppose we have this reaction. Okay? Suppose we have this reaction. Are you done slamming the door now? All right. Now, suppose I say that we add oxygen. I can ask any number of questions. I could ask you, what direction does it shift? Or I could ask you, what do brackets mean again? Anybody remember? Concentration. All right. Or I could ask you, what happens to the concentration of NO? Okay, let's just ask those two questions. So, this is my reaction, and we're going to add oxygen. I want to know what direction does the reaction shift, which will just simply be right or left, or if it's right, what's another fancy word I can use instead of right?
React.
Correct.
Forward or
Reverse.
reverse. All right, and I want to know what's going to happen to the concentration of NO, meaning is NO going to increase or decrease? All right, so if I'm adding oxygen, what's the rule that I'm going to use? Am I going to add or remove rule?
Add.
All right, so if I add, all right, what's the rule if I add? It goes to the what side? I'm going to use a different color here. It goes to the opposite side. Okay, opposite side. So what side is oxygen on? It's on the left or the reactant side. So it has to shift to the what? Has to go to the right or the products. All right, so I've answered the first question. It says oxygen's on the left and it's got to go the opposite side. It's got to shift to the right. All right, so if it shifts to the right, what has to happen to NO based on what we just wrote here? If it shifts to the right, what happens to my amount of NO? It increases. Questions? Yay or nay? Alicia, you with me? Okay. Destiny, what about you? You sure? Bryce?
For the concentration of NO, while it increases.
Anytime the reaction shifts to the right, whatever's on the right automatically increases. Okay? Whatever's on the left will go down.
So basically, like, we want to remove it, the concentration,
Mhm.
to the one's going to decrease, or
So anything that shifts left, whatever's in the direction of the shift will increase. Okay? All right, let's try another one. Let's say that I remove nitrogen. All right? I remove nitrogen. Let's say that this time I want to know what. I'm still going to ask the direction of the shift because you always got to know that. All right? We got to know the direction of the shift, and I'm going to ask what happens to the concentration of oxygen this time. All right, so I remove nitrogen. What's the rule for removal? All right, if I remove something, same side. All right, so if I go to the same side, all right, what direction does it shift if it has to go the same side? All right, I heard reactants. So that's forward, reverse, left, or right. All right, we can say left. That'll be fine. Or you could have said reverse. Either answer would be fine. Left or reverse. Because you said it had to go to the same side as oxygen, or sorry, nitrogen. And nitrogen is here, so the same side is to the left. Are you with me on that? Okay. So I'm asking, what happens to oxygen?
Does the concentration increase?
All right, so if I cruise back here and look at my picture, if I shift to the left, where's oxygen? Is oxygen on this side or is oxygen on this side in the balanced equation? All right, look at where, oops, wrong way. Look at where oxygen is. Oxygen's here, right? Look at where the arrow is. Oxygen's here. So is it over here or is it over here if it's shifting left? It's on the increase side. All right. And one more remove. Let's say I want to know the direction of shift. And I want to know N2 this time. All right. Destiny, tell me what direction you think it's going to go if I remove NO. Is it going to go right or is it going to go left? What do you think? What's that mean? I'll leave it settle for right or left. You don't even have to use forward, reverse, reactants, or products. You can use any of those words. What? Okay. Can you tell me the rule for remove? Got a what? Same side. All right. Got to be on the same side. What side is NO on, Alicia? Throw that in the trash. It's on what side? It's on the right-hand side. All right, so if NO is on the right and you got to stay on the right side, what side is it shifted to? The same side, which is what, Hyro? It's going to the right. Or you could have said forward. All right, so if we got to go forward, what's going to happen to our amount of N2? If we're going forward, what's happening to our amount of N2? It's doing what? Look here. We're going this way. N2 is over here. What's happening to N2?
Why? Right. How on the
Guys.
same side?
You're looking at the way the equation is written. The equation is written N2 plus O2 goes to NO, right? You said it's shifting to the right. Right? What does it say for the left-hand side of the reaction? This whole side does what? It decreases. This whole side does what? Because N2 is on the left side, it's doing what? It's decreasing.
Wait, aren't you removing NO?
Yes.
So you're removing it with the same side.
You're missing the point. Okay? The only thing you need to know about NO is it was removed. You just told me that the reaction shifts to the right. Stop thinking about NO now. The reaction shifts to the right. Now all you need to know is it shifted to the right. This is the part that you use to figure out if it increases or decreases. It shifted to the right. Whatever's on the right does what? Increases. Whatever's on the left does what? Decreases. Because N2 is on the left, it does what? Decreases. Because NO is on the right, it would do what? It would increase.
So it decreases?
What? N2?
Yeah.
Decreases. Yes. So over here, I'm going to write decreases. Yes. Anybody else? Question? All right, let's talk. What's next? Pressure. Pressure most people like because it's an easy one. It shifted right and it was decreased. It shifts right. All right, so just like before, what's wrong, Betsy Bay?
I just need to see more examples.
We're going to do more. We're going to practice more. Let's see if we can get the rules under our belts, and we're going to practice more. All right, so if we increase, that is not a basketball goal. And aside from that, y'all are throwing food. If it hits the wall and there's food on it, it splats, and now I have food on the new paint. Just walk over there and put it in the trash can. Now, if we increase pressure, again, the stuff that is not bolded is the reason. The stuff that is bolded is the rule that you need to make sure you know. If we increase pressure, it will shift in a direction to decrease the pressure. Remember, we're at equilibrium. It's trying to get back to equilibrium because we just disturbed it. It wasn't equilibrium. We came in, we messed up the system. It wants to get back to equilibrium. So if we increase the pressure, it's got to find a way to lower that pressure back down. So anytime we increase the pressure, it has to shift to the side of what? Fewer moles. Increase the pressure, you're looking for where there are fewer moles. So how do we find moles again? Coefficients. So all we have to do is balance the equation and find the fewer coefficients or fewer moles. So if we decrease the pressure, same thing, except we're looking for what? More moles. Okay, because the equilibrium system is looking to find a side that has greater pressure. What's wrong?
Hey,
Okay.
I was getting started. New seats. We got point six. Anyway, I got point one. We got point five.
I need to choose.
I'm sorry.
I'm so sorry.
That's emergency work. All right, we caught up? Everybody got it? All right, so suppose we have this equation. Suppose we have that equation. Now, we've all seen this equation many times. Now, there's only two things we can do. We can either increase the pressure or decrease the pressure. It's not like I could change the pressure on various compounds. I can either increase it or I can decrease it. Now, notice in parentheses I put volume there. If I increase the pressure, that's the same as doing what to the volume?
Increasing it or decreasing it.
Increase
Don't increase the pressure.
Yeah.
that's a small.
Decrease. Volumes. PBT.
PAV inversely proportional.
Oh, snap.
Pressure and volume are inversely proportional. What does it mean to be inversely proportional? They're opposites of one another. This is where it's killing y'all. Okay? Where y'all can't recall stuff that we've already done. Pressure and volume are inversely proportional. One goes up, the other goes down. So if I increase pressure, volume goes down. It takes up less space. So, if I look at this reaction and I increase the pressure, all right, suppose I ask you, what happens to the concentration of hydrogen? Okay? What happens to my concentration of hydrogen? Again, the first thing you have to know is what? Does it shift to the left or the right? You got to know that before you can answer the question. You can't answer the question until you do know that. So, if I increase the pressure, what's the rule? It goes to the side of fewer moles. Okay? So, if it goes to the side of fewer moles, is that to the left or is that to the right? All right, everybody said right. That's fabulous. How many moles are on the left, just to make sure we're all on the same page? 4. That was good. That's a whole bunch of people yelling 4. And how many moles are on the right?
2.
Very good. I like that. That's a lot of voices all yelling the right answer. All right, so everybody said it shifts to the right. So we seem to have that piece. It's the increase-decrease part that's killing us here with the hydrogen. So if we look at what we just did a second ago, and put in another page without all the writing. Anytime it shifts to the right, what happens on the right-hand side? Everything that's on this side will increase. Everything that's if it shifts to the left, whatever's on this side will do what?
Increase.
And whatever's on this side will do what? Okay? It never changes. Doesn't matter if we're talking concentration, pressure, or temperature. So, if we write the equation again, we have N2 plus H2 goes to NH3. Coefficients don't even matter. I'm asking you what happened to H2, right? So I'm talking about hydrogen right here. I want to know what happened to its concentration. Y'all said it shifted which way? It shifts to the right. So if it shifts to the right, all right, shifting this way, it's going to increase. Let me shorten my arrow here.
It decreases.
Maybe not. It's going to decrease this side. So what's going to happen to hydrogen? It's going to decrease because hydrogen's on the left
If it
side.
was going to the left, it would increase.
If it was left, hydrogen would be on the left, so it would increase. That is correct. Okay? So back to my question. Next to hydrogen, I would write that it decreased there. Are you with me? All right, so let's just say here that I ask what happens to ammonia. And let's ask what happened to nitrogen this time. I'll ask what happened to two of them. Okay? So if I decrease the pressure, what's the rule? I go where? If I decrease the pressure, I do what?
With the more moles.
More moles. So if I go to more moles, which side has more moles up there? Okay, so left or the reverse side. All right, so if I come right back over here where we were, let me rewrite all this and all that crap on it. N2 plus H2 goes to NH3. Okay, y'all said it was going left, so we're using this, right? All right, so I asked in the question NH3 and N2. All right, so tell me what happens to NH3 first. NH3 is going to do what? Decrease. All right, so next to that one, we're going to put decrease. And I want to know N2. So next to N2, what you going to tell me? Yep. Anybody have a question that didn't get what I was doing? Destiny, you with me? Don't just nod yes if you don't get it. You really got it. Alicia, what about you? You're always quiet and won't talk to me. You got it? Uh-huh. Rebecca? Yes or no? Don't just yes if you don't get it. I'm trying to call on people who won't normally talk to me or yell out answers. My less vocal people, I got to call on y'all. Yes.
Oh my God.
So what now? It would increase, yes, because they're opposites of each other. Trent, what about you? You're not usually very vocal over there.
Yeah.
You with me? Shut up, Gabriel.
Yeah. Wait, what?
I was asking if he was all right, if he had questions. You with me? Okay. Anybody not with me? Tim, what about you? You with me? Question? You sure? All right, last thing is temperature. Oh, no, we need to talk about this one. Tell me about that one. What would happen if I increase pressure? If I increase pressure, what would happen to the concentration of HI?
That would have changed.
Why not?
This is a gas.
They're all gases. And the last question, too.
Oh, they're balanced.
Wait, what?
What do you mean it's balanced? The last equation was balanced.
There's no, there's
They're
three.
gases.
There were gases in the last one.
They goals.
There you go. All right, if we go here, these are all gases. They're balanced. Both equations are balanced. The piece you were not saying, even though you were thinking the right thing, is that you had 2 moles on this side, and 1 plus 1 is 2 moles on this side. You had the same number of moles on both sides. So you don't have more moles and fewer moles. You have the same number of moles. Pressure is the only one that it might not shift in, and it would have no effect. Okay? Concentration will not work that way. Temperature will not work that way. But pressure could have no effect. Okay? And I don't think we need anything to have under there. Yeah,
All right, I'm gonna write it down.
that's fine. Look, you dumb thing.
Is it?
Yeah, pressure. Look, you dumb board. All right, but pressure is the only one that can have no effect. So in this particular case, there's no effect.
How are you guys?
So you do, oh, you,
What's that?
All right, anybody else need it before we do temperature?
Hold on. You didn't do that? We're not-
All right, temperature. All right. We can remove or add heat. All right, so if we remove heat, it will go to the side to produce heat or make heat. All right, so if I remove heat, it goes to the warmer side. Makes sense. Okay, anytime we remove heat, it goes to the warmer side. So the opposite of that, which I forgot to bold, by the way, this should be the bolded side. We add heat, the part I'm underlining is the bolded part. It will go to the colder side. Now, part of these I'm going to probably skip because I think I've got extra in here we don't need. Now, these are where our thermochemical equations that we wrote down are going to come in. All right, I don't think we need any of that. We don't. All right, we caught up? Everybody got the two rules?
Yeah.
Destiny, tell me when you got it. All right, we're there? All right, I don't think we need this because we should be okay on that, right? Everybody's okay that heat on this side is endo and heat on that side is exo, right?
yeah.
Okay. All right, we should be at the same. Now let's write that down.
Yeah, so you.
All right, we're there? You're nodding yes and your eyes are closed with your head on the table. Oh, okay. All right, we caught up? Now, these I tend to think are some of the easiest ones we do. All right? Can we all agree that this is the heat?
Yeah.
Okay? And I used to teach these in a much harder way. And then I was like, why are you doing it that way? That's stupid. That's bad. Why are you talking over there?
She doesn't have rhinos.
All right, so tell the rest of the class the answer.
I think we had KJ.
Okay, that's fine. That's a good answer. It's also the number. Okay, KJ Mole's a good answer too, but it's just the number. Okay? The symbols are the elements and the numbers the heat. Okay? So, now, I used to teach it a completely different way and make people figure out that that's exothermic and the reverse reaction was endothermic and make it much more complicated until somebody asked me a question years ago and I was like, why are you doing it that way? That's really stupid and really hard. Why don't we do it the easy way? So that's the heat, right? So if I add heat and that's the heat, right? That means this is the warm side of the reaction. If that's the heat and that's the warm side of the reaction, what does that mean this side is? Yeah. So, according to the rule, if I add heat, the rule is, whoops, I forgot I got all this other crap in the way. All right, if we add heat, it's got to go where? Got to go to the cooler side. So, let me take that slide out. It's got to go to the cooler side. So, it's got to shift where? It's got to go left or reverse. So, if it's got to go left or reverse, if I just asked you what happened to oxygen's concentration, y'all would tell me what? What would you tell me if I asked you about oxygen?
It decreases.
All right, I got two different answers, so we ain't got it yet.
Increases.
Okay, so a bird probably just knocked himself out and is laying on the grass. Wow, sometimes they just bump and fly off, and sometimes they lay unconscious on the ground and then they wake up and fly off. Huh? Is he laying in the grass, Gabriel? Oh, well, the chances are he's not dead. He's just.
Didn't hit it too hard.
He hit it pretty hard. We haven't. Salma, stop pulling on the blinds like that. They didn't buy industrial strength for in here. Guys, it's just a bird. That's what we're going to talk about. It's just a bird. It just hit the glass. It'll be fine. It's like the Windex commercial. Wham. We did too. All we did was hear it. Huh? Really? Just now?
Earlier they called ambulance.
You're a kid. He'll be sad that he missed that. Poor Dukes. Do you know which one it was? Who? Heaven? Sparks? Wow. Okay. No, they passed out apparently. All right, so
Right now?
next door. So if we look at O2 in the reaction, we got two different answers. All right, so if we cruise to our, I'm just gonna redraw it rather than draw it over there. All right, so if we say left, all right, what happens on this side? What happens on this side? All right, so I got two different answers a minute ago, right? Look at where O2 sits in the reaction.
Oh, yeah. Oh, my bad.
Okay.
I was confusing it with when it was to the right.
Okay, so if I remove heat, where's it going?
To the left.
To the warmer side. What side's the warmer side? To the right. All right, so if I asked what happens to, let's just say H2, what's going to happen to H2 if it shifts to the right? It will decrease. Now, you think we can practice? What do you mean no?
Hold on.
Now, don't pass out. I have no first aid skills. All we can do is leave you slumped there until some EMS people get there. I'm just telling you. Hey, I got nothing.
Okay.
I feel like teachers should be certified.
Yeah, I see what
I got certified in CPR 20-some years ago. I've got nothing right now. I have had one student pass out and vomit projectile like probably, I don't know, 7-8 years ago now, banged his head in the lab counter. That was nasty. Short of that, it hasn't been real bad. I've had two have an anxiety attack laying on the floor and try not to hyperventilate.
What I took is so scary.
short of that, I've done real well over the years. I haven't had a lot go on, but the projectile vomiting, that was slimy. That was nasty. Kid that was sitting in front of him, though, he didn't take it real well. He was covered in it. Now, you remember last week, I told you that the equilibrium constant K depended on temperature. Okay? And I told you we would not learn the rules. Now, these are the rules that actually go with that. K changes depending on temperature. So if you increase temperature, K will increase or decrease depending on whether the reactions are endo or exothermic. So if you think back, I told you, those of you who one day, I don't know how many of you, I know Destiny told me she wanted to go to nursing school and would have to take college chemistry. Those of you who would one day have to do that, your college professors will make you memorize these rules. This is not part of our curriculum, so I'm not making you memorize these rules. So find the worksheet that we had on Friday, I'm pretty sure. The people who were absent, these ones. All right, it looks like this. We did this side on Friday. You need the back side today. Anybody else out besides Gabriel and Trent? Okay. Now, on the back side.
Let's say a bunch of
Sometimes it's not, it's so bad. And then like, let's say you want to do. Because I watch it, like sometimes I watch it, but if there's warning, but you don't, I think. No,
I saw it.
All right.
I just looked at it.
This is the part where you stop talking and shut up. All right. Number one's filled in for us, so let's ignore that one. And number two, we've got a reaction. It says add hydrogen. What's the rule for adding a reactant or a product?
Can I get one
All
of
right.
the papers?
Where's yours? All right. It goes to the opposite side. So if you go to the opposite side, all right, where's H2 in the reaction? It's on the left, so that means it has to do what? It has to shift to the right. So if it shifts to the right, what happens to the stuff on the right? It increases. What happens to stuff on the left? All right, that's why I wrote that little D and I right there, just so you had a visual. So where is N2? Is it on the left or is it on the right of the arrow? It's on the left, so it's going to do what? Where is NH3? So it's going to do what? It's going to increase. Now K, I'm not asking you to fill the column for K in, but what's the only thing I told you would change K? Temperature. So it's basically going to remain the same. Now, if you want to, you can go all the way down to here to temperature, and you can write change. They're all going to remain the same for anything except temperature. Now, for the ones that are temperature, there are rules for that, but what I tell you, we're not going to learn it. Okay? But K, the only thing that changes K is temperature. Everything else is going to leave it the same. I want you to fill in the rest of the chart. You can't find it. I'm going to see if I can make a copy because this is Juliana's and somebody else who's absent.
Oh, God.
I showed you, but I don't think she needs them.
I really thought somebody hit their head.
She actually does make up her work when she's out.
Yeah, I thought somebody tried to keep doing it. Just like, what is they doing? So it's all very equal with them. That's a New York sheet. Oh.
That first trip. The first probably found some Dylan Scoop.
I'll take that joke too, bro.
What was that? Next time we can just.
Tim, it's gonna be this pill, bro. I'll take no pills. That slow, bro.
But then
That shit had me goddamn. I remember.
If you can't sit down and we can't practice, then we will move on.
Where's Clippers?
I have image to the opposite side. The image is to the
I'll tell you what the other
left,
side.
so it shifts in the
Let me see what you broke on.
left. Into remove things that are
Because when you remember it, says no.
that's the root. And the arrow goes up.
Drop on top. Cool.
Wait, what?
Look at these on the foot.
It's almost like
Here, Monday, what I'll say. I'll
I'll
say it Monday.
The last week.
Last week.
The first week of.
I got to, I got
It's only
to.
like,
I got
say
to.
that ADB didn't. Take chemistry exam on. Yeah.
Why is it?
Second, June 7th. Yeah, we're the third exam
Well, that's the worst.
because they're doing 4, 3, 2, 1.
4, 3, 2, 1.
Starting with fourth, something about seniors and the number of seniors who have a fourth period exam versus a first period exam.
So, wait, what?
What is?
That's the
I'm not trying to.
Yes.
I'm kind of glad we're taking this forward as hers, but still.
Hers is, yeah. And she said no, there's no way like this whole pass the exam. I'll pass it, but. That's not.
Oh my, this is a reality today.
All right, how many do you have left to go?
I'm going to number 6.
Okay. What?
What are you about to do?
Nothing.
Yeah.
No.
Okay, then it's like,
It's what?
So I know.
It's just
or
like.
shifts the side.
Let me tell you what you broke on the next.
Same side. So you remove
This
from
is
the same side. So you remove into.
Yep.
Yeah, I don't get those.
Do not know.
It's You know how to do it?
Was it one like this?
Did I go back and match that?
Oh.
This? You lost your graphs we did.
Sophie.
Was it?
And Bailey was behind me. And somebody was like, I'm meant to say
Oh, yeah,
something in the group chat. And I turned around and Bailey was looking at it.
It's on the back of this. And I have this one. It's on the back side.
I got the leg stick to your race.
And then what's the homework from my night?
Stop.
I work for May 9th.
Why? So what? I need help with the rules.
I'm pretty sure I got like half the wrong. It was the one with multiple choice.
Oh.
Oh, what is the one that was stapled? Would have been that. Never mind, I got an answer already. What's your question?
We need help with remove because it confuses us. It says remove reactant or product.
You guys are the same size.
I'm ready for. Okay, so here, answer.
So it's going to the left.
I used to have one.
Yeah, you wrote the same size. Inches on the left, so it's got to go to the
It's like
left.
there's
You're
three.
pointing to the left.
They switch all the like core classes to, well, they switch art.
So it's on the left, and then H2.
A couple other classes, they switch to first.
Alright, so those two would be opposite sides, so H2's opposite would be right, and H3's opposite would be left.
And very much, it's like the
Same
same.
stuff, it is, H2 would be what?
Left button.
Yes. Removing H3 would be what?
Right.
Yes.
First easier. Pretty bad.
Fill in the rest.
The last year was pretty bad.
I don't know, my last year there was.
Yeah, it goes to the left. What happens? What happens here? What happens there? So whatever's on the left will increase, whatever's on the right will decrease. So that's H2 is on the left.
You have to have the first
Will
one.
increase, whatever's on the right.
And they see the table, don't take
Yeah.
So into.
Pressure is increase goes to less volts. What side has less volts? Yep, so it's going to what side? Yep.
No.
Now, what'd you just say?
Learned on.
Right. You got a label 2 up here. 2 has fewer volts, so right.
Oh.
And increased pressure goes to the side of,
Left or right?
well, that's a decrease. Answer the D. Okay, so decreased pressure goes to the side of more volts, so, yeah.
Into.
And then you fill in these just the way you did those. So if it goes to the right, whatever's on the left is gonna do what? Decrease.
Good.
Hyro, you've done 3 lines. Can you do a few more?
This wall.
Hey, bro.
Oh,
Already put you together, bro.
You use.
Go to the colder side.
Oh.
What side doesn't have heat?
Yeah, left.
Yep.
That makes one of your socks. She's
Also,
making for your socks.
into.
Yeah, bro, I put the wrong
Colder
socks on this
side. What side
morning.
doesn't have heat? Yep,
Oh, it's tired, bro. I woke up literally just like as soon as I got out the shower, bro.
yep.
My cousin called me and I was just talking. I was putting some socks. I'm like,
Shifts to the side of your home. Instead of K, or into the same. To right, you get
Yep.
increase on 7.
Question?
Did you get for 7 on shade?
If you add, it goes to the opposite side, so right. Add H3 will go to the opposite side. Add this, the opposite side is what? It's on the right.
What?
So that's your left. That's your left.
Change? Are you serious?
Yeah.
Okay, we'll change it. And this is all
So if you remove into, it'll be the same side,
And
so
A is
left,
changed to.
left. Yes.
I'm really good at wrong, Pyro.
Alright.
Increase temperature is added. I put decrease and increase, but you said it would change
Where?
on 7, 8.
Change where? Yeah, well, they're gonna change. That's how it is. That's too straight. Almost. Who else has a question? Can we go over the answers?
No, hold on. Increase temperature.
We can't go over the answers, Destiny?
Not yet.
Say,
Why?
Because that's the
it's a decrease.
I'm good.
Well, I hope Trent and Gabriel are good since they're playing on the bus. You two done? You got it?
Yeah, I think it's this way.
Alright, how are the ladies?
See that, Jim?
What?
I was right.
Jackson, based on
I'm
what?
right too.
I'm gonna be the very best. Whatever was.
I got it now.
Right.
Yeah, 'cause it's got two.
That's why I got it before now.
All right.
Okay.
If you decrease pressure, it's the side of more moles. What side of more moles? Uh-huh.
Check 7 and 8.
You increase temperature, goes to the colder side. Colder side goes down. What side has no heat? So it goes left. Right.
Increase temperature. Wait, 12, 13, 14. I thought I'd been like,
Go to the colder side.
no, but she's gonna do it. So, I did it right, but it's just the opposite.
Yes.
Oh my gosh. You know how to do it.
All right, can we look at some answers?
No. Yes.
Sounds still yelling no.
Me too.
This what you got?
I think I got it. Mine's in my head.
Get out here. Out of the microwave.
I'm trying to think of
So, if you go back there, microwave.
And seeing how it's my microwave, it's always nice to be asked.
Oh, I used your microwave the other day without asking.
I did it that.
All right, so if we look at number 3, if we add NH3, it goes to the left. All right, it goes to the opposite side, so it's going to be left. All right, if it goes left, that means N2 will and H2 will. Good. If I remove N2, it will go left, which means H2 will and NH3 will. If I remove H2, it will go left because it will go to the same side. So N2 will and NH3 will. And if I remove NH3, it will go to the, and that means N2 will and H2. All right. If I increase temperature, it has to go to the colder side. And remember, this right here is your heat, right? Now that I wrote that right, but that's heat. So the colder side is this side. All right, so that means it's going to the left. So that means N2 will and NH3 will. All right, so if I decrease temperature, I'm going towards the heat, which is, and that means
Decrease.
and,
Increase.
all right, so I've got to raise my paper here. So if I increase pressure, I go to the side of
Right.
the fewer moles, so that's right. And then I'm going to have decrease, decrease, increase. And if I decrease pressure, I go to the side of left of more moles. So I've got increase, increase, and decrease. All right. We're going to practice a few questions. We probably won't get, I think I made up 7 on Friday. We probably will not get through all 7. We might. All right. I'm pulling up the Plicker. If you remember your Plicker number, grab your card. If you don't, I'll have it up in just a second so you can see what your number is.
Probably 17 or 19.
I think I do 7.
So I said, if you don't remember, as soon as Google comes up, I'll.
I swear I was slow.
I am number 1.
17. Oh yeah.
This is good.
It's just slow, so it's got to load.
It's 9, isn't it?
Okay. Wow. Christian.
Yes.
Ruthenia. Chemistry.
Oh.
Told you I was 12. I'm 10. Oh, okay.
Find your numbers.
Oh yeah, I got my castle.
Maybe like in the beginning of the year.
All right, do we have our card?
Honestly, I'll wear like a hoodie.
Well, you can choose your own number. She already chose it for us. I know.
All right. And again, this is using Le Chatelier. This is not calculating or anything. This is all on shifting.
I gotta be okay to see.
You know what's on that candidate?
Oh. No, these words are smaller. You see that?
I'm trying to figure out how to do it.
I'll tell you later.
If pressure increases now, look, she made it big.
Yep.
I forgot to take C and D off the answer choices. All right. Now, the only thing about these is I could not make the subscripts, so the twos that are at the end, of course, are supposed to be subscripts, but there's no way in Plickers that I can find to make those subscripts. I need to go down and ask Miss Miller if there's a way to do it, because I know she's been doing it longer than I have.
Concentration.
All right, if pressure increases, what happens to the concentration of oxygen?
I got you.
Okay?
D.
Hold on, let people have a chance to think, and then it's easier to scan all at once than it is to constantly rescan.
Everybody got their thing good. Hey. Big B's.
Back there, so hang on. All right, Tim. I was gonna say, you gotta turn it around. I cannot scan the back of the car. All right, ready?
Wrong tripod, Ms. Wolf.
Ding, ding, dong. All right, looks like we got 14 right and 2 wrong. All right, if I increase pressure, it goes.
On interruption, do you have Destiny here?
Yes,
Did you send it to Ms. Harvey's office for 1 moment? 1 moment, please, sorry.
I will.
It's hard.
Thank you.
Thank
It's
you.
already.
Shut up, she doesn't want to talk to you.
She do.
She does not. So if pressure increases, I go to the side of what? Fewer moles. What side has less moles? To the left. All right, so if it goes left, oxygen will do what? Decrease, which is B. All right.
To the left, to the left. Ever know?
There we go. All right, if temperature is increased, what will happen to the concentration of water? Temperature is increased. What will happen to the concentration of water?
I got you. Yeah. I got it. I'm ready. Promotion. I'm ready. I said. Boy, somebody is B bad.
What do you get?
It's A.
Words confuses me.
It's A.
It's A.
It's A. Why would you say so?
All right, so we got 2 wrong and 13 right. So if temperatures increase, what side do I shift to?
Colder side.
Colder side, which is to the left. So if I shift left, what happens to my water?
It decreases.
It decreases.
Everything you own.
Alright.
Drops to the left. I really feel like I would know more stuff in chemistry. When I come out to this.
All right. So if oxygen is removed, will the reaction shift right or left? If oxygen is removed, will the reaction shift right or left? That's all I'm asking, just right or left this time.
You're thinking you're irreplaceable. So go ahead and get going.
Ready?
It's the NBA home. But you think I was kicking you out?
Well, straighten up a little more. There you go.
Wasn't true.
It's on the same cycle.
Yeah, I forgot the part. You better do this. Hurry up before your taxi leaves.
Alright, so we got 14 right, 1 wrong. If oxygen is removed, the reaction will shift to the left. It goes to the What happens to the concentration of oxygen? If temperature is decreased, what happens to the concentration of oxygen?
My goodness. Oh, I got a different answer choice to choose from. The temperature is decreased.
Mm-hmm.
Yeah.
Why?
No, I know. That's all. Just like I was just hoping for like
Okay,
something to be A. I doing a pick A one time.
I don't pay any attention to that. Same thing on the test. I don't pay any attention.
I had like a whole list of B's on the benchmark.
I remember one time we made a mistake and I almost had
I said, oh,
I
stop.
like 4.
Me too. I said, bro, oh, that's scary, bro.
our whole entire test.
Ooh. Uh-oh. Uh-oh.
Jennifer, you got it?
what in the world?
Well, it didn't scan.
You better lose the attitude. Tell me.
I just feel like I'm home. Out of middle school. I feel like I'm home. Trent, you got one?
Oh, it's my girl.
All right, I got 12 right, 3 people got it wrong. If temperature is decreased, I go to the,
I mean,
just to the left oxygen. It decreases.
I could
All right. Last one. What is it? Reaction shift. The concentration of O increases. Which way does the reaction shift? Last question. Which way does it shift?
How about throw up A, bro?
You know,
You put up A, bro?
no, bro, I'm E.
No.
Hey. Yeah.
Did you get mine?
No.
No, I
You got 9 wrongs and 5 rights. Did I put the answer wrong?
What was the answer?
If I increase NO, then it goes to the opposite side, which is left.
Oh, hey, bro, time is.
10:20.
Oh, when the time was 10:20, don't be putting me like that, bro.
That's why I was gonna.
If you will, put your cards on the desk. You have homework with this tonight. I want you to do 1 through 6. You do not have to do the math problems at the bottom. Just 1 through 6 on shifting. They are not multiple choice, by the way. For those of you who cannot figure that out, they are individual A, B, and C. Tell me left, right, increase, or decrease.
Yeah.
Believe it or not, some people actually read. Think when they read this, the multiple choice questions. They're not multiple choice questions.
Break your head.
Where's my water?
That's Leandra's crap. She's got her paper. How's everybody on that row? There's 1 for Liliana.
Miss Walker, thank you.
No,
What are you doing?
you have a teacher. It's called Mr. Dukes. I don't care.
1 through 6.
1 through 6.